Welcome guys to today's project. Today we are working on a ramp, and let me run the project from Revit and show you the project. So the first design was done on Revit 2021. I'm using 21 version, and it's your guy Paul Mohende. For our project, any green clicks will be the left hand click. I'm at the left click on the wheel, and any blue or cyan will be the right click on the mouse. So here we have a project. It has already loaded. Let me just zoom in. So this is a ramp that you're going to design. So there are two ways. Okay, there are a number of softwares that we can use to design, but as of today, we're going to focus on Prota. So Prota has three main streams, which is ProtaStructure, ProtaSteel, and ProtaDetail. Us, we're going to use ProtaStructure for our case, and later ProtaDetailing. So as of now, the ramp has two flights and it connects two floors. So this is the ground floor and this is the first floor, then first floor to the second floor. So using the British annotation system for levels. So for our case, we're going to design this in Prota. But there are two ways to go about this. You can either export the whole of this project, but some Revit families are not going to be exported to Prota. And you can start the project afresh in Prota, and that is the route that you're going to take, and you're going to now do it from step by step. So without further much ado, let me show you how to export to Prota. Just come here. So for you to get this plugin, you have to go to the official Prota website and then create an account first, a free account, then download the plugin. So just come here, export to Prota, then a dialog box is going to be launched. So from here, just come here, create new project, and it's going to be called ramp. So over here is where you specify the location where you want to save it. New project, and the name of the project is ramp design. Over here is where you specify the template. So for our case, you're going to use the United Kingdom Eurocode, or you can borrow from previous projects here. So United Kingdom Eurocode, click on OK. Then it's now going to export. So over here in this dialog box, you need to marry the structural column to the columns in Prota so that it integrates and becomes as one. So for this section, make sure you click on the same section, then just click on this button, add this section with that section, click add that section with that section, add, and that's it. If you need to create new members, just come here and create new members for the steel structure section. But as of now, we have all the members, and it's okay. For the depth of foundation, just specify here, but this can be well known after geotechnical investigations on site from a civil engineer or a geotechnical engineer. So just click OK, and it's going to export. After that, it means it has already exported. So just come, launch Prota. We are going to use 2021 version. So I have two versions, 2021. So this one, and I have Prota 2018. Just open project and just come and locate it. Just come here and look for choose or create, and there we have it, ramp design. Just click and open. So kindly remember, there are some families from Revit that are not going to be important to Prota because they are not structural part here, such as a roof here. So this beam member length is 0. Just click on OK. We will redraw in Prota. The same for that one. Project is loading. So the ramp is located here. So after it finishes loading, just come here. You can just look at it at 3D. So this is a 3D view. Just remember, there it is, and this is the other side. So it's still reading, so I'm gonna just hide that, and this one I'm going to place it just on the extreme right hand side. So there we have it. So over here, so for you to rotate like this in Prota, just hold down your right button of the mouse, and it's going to rotate like this. And this one, for it to rotate, hold down the shift button and your middle wheel mouse button to have this. So you see there's some members which have not been imported, but the columns are there, the beams are there, the slabs are there. But the only thing that is not right, it's this wall. So Prota sees it as a shear wall. So that's why you can see the class of the material, the last point, it's given the concrete class of the wall, but it's just a masonry wall, okay? So for in the event that you're going to use this, we could have just changed the properties of the wall and that will have been it. So for our case, you're not going to use the beam importation process. We're not going to use this. We're going to use a different one. So you can even watch, you can even check from here. So this is new. Some things have been changed while importing to the system. Some things can be deleted and some things cannot be changed. Okay. So yeah, today we're not going to use this. So I'm just going to close it. It's a blank new sheet. This is where the project starts, and this is what you're presented with, and this is story 1. So you just come here at the building set out. You can just look at the settings that you have. You can change the materials, the class of the concrete. You're going to use class 20, 25. And let me show you what we're working with. Before starting any project, make sure you've come up with this. So this is just a brief summary of what you're going to use. So the concrete class is class 20 or 20 newtons per square millimeter. The strength of the steel is 500 as per dimension shown. The slab thickness 150, column size 300 by 300, beam size 300 by 450, and that's the breadth times the depth. And the design is to Eurocode. This is a plan view that you're going to use. So before the design, make sure you do the check for the slab if it's two-way or one-way. So LX over LY, where LY, and also come up with the elevation. It saves on a lot. You save on wasting a lot of time and also making silly mistakes. Okay, then without further much ado, let's go to modeling. Just get the grids. So just start with one grid and then offset the others. It's rather easy like that. Yeah, just one. So that's 10 meters, rather long, so 5 meters is okay. Then from this one is where we're going to produce all the others. So just offset. Hit escape, and this is the way it's gonna look. So for these ones, we're going to edit to hide this, the annotation here. So come here, member table, axis table, and change the label option to blank on either side and press enter, then just close. So yeah, that's the way it's gonna look like. To start now on our beams, and then we're going to do the slabs. Columns will come last. So come here, beam, specify from here. We are working with a beam of 300 by 450. So come here, B 300 by 450. Okay, then just click on the outside, drag, just move your mouse and then click again on the outside. So they're saying they're going to cross over, just say yes, and that's okay. So that's the way we have it. There's a gap between, and there's a beam formed at the center of these two beams. Just click on it and delete it. The same for this one, click and delete. The same for that one, click. So change to 3D. So this is the way it looks like. So we can have both. So 3D and the normal one. So just click on one and just come here, right click, change to plan view. Yeah, so to have both views in display, just come here and just select the title vertical. Remember from our elevation what we have. So this one, the landing is at 1500 and this one is at 3000 and this one is at 0. So it means this one is a landing at 0. This one should be at 1500. Okay. So let's go to story 2. We have to create a plane here. So go here to modeling, create plane definition. So a plane where it's gonna sit. So this beam region, click on it, then click on the plane one, change it to negative 1500, negative 1500, negative 1500 because it's even. Update, then click on it, right click and say move members to plane. Yes, so that's they have moved, but I wanted for story 2 not story 1, so just undo. Make sure you're clicking on the P on the plane. So there we have it, and then we're going to move this one to this connection. Okay, so this one is going to go up by positive 1500 and meet this one. And this one of them is going to go down by negative 1500 and meet that other one. Okay, so what I mean, just come here, definition, just for this one we want the whole of it, not just one but the whole of it. So just come here, pick points, so this point and this point and this point and that point. Okay, click on that to close, then specify. So this is point 3, is it point 3 or point 1? Confirm this is point 1 and point 2, so this is point 3. So point 3 is at negative 1500. Update, come here, click on E2, right click and say move members to plane. Yes, so that's the way we have it. Okay, and this other one we're going to put it at positive 1500. So there we have it at the center of the floor, and here we should have, over here we already have an existing slab. You turn like this and you check the floor 1 and floor 2. So over here we have story 1 and over here we have story 2. So let's make the landing for story 2, which is going to be positive 1500 also from this one. And for story 1 we're going to, it's gonna be left like this. So these ones, I'm going to offset this one to this level. It's going to be offset by 4500. Okay, so just click on it, right click, properties, go to 3D, specify 4500 by 4500 and update, and there we have it. Okay, so the same for these other ones. Click and just hit escape, click on that one and that one and then that one, right click, properties, we have to add the columns to this place. Okay, let's start at story 2. Here, column 300 by 300, that region. Okay, so like that. Generate. Yeah, so that we have now that continuum. Okay, so for this one we also need a landing here for this section, and that's story 3. Actually, yeah, inside story 3 total number. So this one over here. Then we can draw our landing. So we need columns for the other floor, or we can edit the height of these columns. So the height, and change it to positive 1500. Then we'll just go to analysis, then analysis, the column, the beam, and then the steel member, design check. Over here we do have the analytical model. This is how it's going to look like. But there's something that you had not changed, so we need to change these slabs from the they're not part of the diaphragm of the structure. They behave separately. So just come here, the analysis. So no rigid diaphragm for floor levels. Okay, then do the analysis yet again. Brings no error. It's just because, just to be extra keen, just merge vertical columns. Close. So you can get the reports from here. We can check if the columns okay. So the columns have passed with D12. That's good. The beams are passed. You can just click on maybe one and see how it looks like. So with also D12, which is okay. So for our slabs, I've just remembered we did not specify the loadings. So just come here. And close the analytical model we have here. So over here we can look at the displacements. So this have seen them clearly. But back to the 3D, just come here now to the design. So I want to go to the floor plan. So plan, and I want to provide a footing. So I want it to be in a square design, so a meter by a meter it's passing. So I want to look at the rebars. So I don't want any top. Just the bottom. So it's using every combination that we have. The class of concrete. Okay, it's successful. So let's use 450. 50. Okay, so it's gonna update here automatically. We have the 3D view, the reinforcement. That's the way it's gonna look like. Okay. So I see we have these bars. I don't want them. So that's the way it's gonna look like. Okay. So it's that fast and that smart. So just go to generate report. So instead of doing that for all the columns, you can just delete that one, and then for these ones we're going to use the same type of pad footings. So click here, insert pad footing. So it's going to do the analysis and just passed at 4. There we have it, and over here we're going to use a combined footing. Let's try this again. Yeah, so as of now it's passing. So 5. Okay. Yeah. So let's try. There we have it. Okay. So back to 3D. Everything is there. You come here. We provide design everything. At the settings, let's change something. So for the slabs, we're using interior support 3.3, and for the rebar, the minimum I want it to be 10. No, because it's a ramp, you can adapt 8. So here's where you can change a lot of the settings. I don't want any top bars from here. You can just undo that, and that's it for now. So back here to modeling, select the slab strips, start here and here. Then start here and here, start here and here. Okay, then after that you can do this one. So start here and end here. There we have it. But because of all the juggling up of the annotations, you can just do at the corner. So you can start there and end there. Start and there. So the 8, and that's spacing. Then because of the different spacing, we'll have to change that to a uniform spacing. There, and from there to there, and there to there, and from there to there. Okay, So far we have the detailing for story 1. So we go to story 2. And get the reports if you want to. Just get the quantity also, concrete. Let's know how much concrete we're gonna use. So a total of that is 7.569 cubic meter. You can just generate a report over here. You can also get a report of the total formwork that you're gonna use. So generate the report from here. You're gonna have it. You can either save it in PDF format, just click on this, or in Word, to a photo, to web. You can just print it directly from here. So after that, you can just come here, report manager. From the report manager, you can select the logo. You can load it from your system. You can select the font, the size. Then you can add all the available reports in the project to be combined into one. So after taking them over here, just you say view as it combines all the reports. Then after that, you can just have a glimpse of the columns, the way they look like, maybe just story 2. So this is a column application. You can change the way it's arranged in the settings, actually in Prota. Then elevation. So back here, let's go to settings. Now let's be specific with what we want. So for the columns, we go to the rebar. So we do this one, we select we want this one in the event. For the walls, we have no walls. For the longitudinal bars, minimum that, maximum as that. So maximum as 20. So the spacing 200 maximum. We go to the links, we say maximum 250. That's that. Okay. Then we go to the detailing. So you want it, how do you want it to be? You want it like this, the kicker, the depth, so like that, the type of link, open or closed. So open. So the elevations, how you gonna see them, like that. So we can also include that. Okay. Then the schedules. So we can have the link details. Then you can have an outline on the change. The beams, you can just look at the design, the parameters that you're using, the minimum, the maximum, the minimum number of hangers. So this is where you change all that, okay? For the foundation, for the ribbed, and for the floor. So the maximum spacing for the links also, you can adapt 250. This is when after you've already done the test and you've already done the analysis, and you know how they're gonna behave. So there's different ways of reinforcing the patterns, pattern 1, pattern 2, and pattern 3. So for bend up bars, it's where we bend the bars at the center, because here it's where we have maximum bending moment, so 0 shear. So for us to do that, we know that steel is really good in bending, so that's why we add more steel here, but concrete is very weak in bending. That's why there's less area of concrete here. So for our case, we're going to use this one. I prefer this one. So for bend up bars, we're not going to use that. So the links, it's like this, closed links, or you can use open like so, but we use closed. Standard is the same as closed to some extent, but we can also adapt standard, yeah. Curtailment is where we can curtail the bars, at which length and the distance. That one I'm not going to change. The detailing, the drawing. So for this one, we can put it, we can write at the bottom and the beam. Okay, the sections, just different beams, but not all beams, and we still need sections. So for these ones, the annotations, how do we want them to look like? So we change from here. I prefer mine replotted below to show a clear detailing of what you're doing. And there we have much of it, detailing and how it's going to do. For the slabs, we change that to the design, the rebars. So the maximum, I want it to be at 200 and the minimum at 100. Okay, so that we maintain standard appearance. So show number of bars, okay, but don't show the total length. Okay, so the foundation, actually we can show the total length and the number of bars. It's okay. So from here we can go to the rebar section and we can specify, show additional information like that. So it shows if it's bottom or top. Okay, yeah, so here's where you can change some things if you want to. If you want a hatch, usually go with that one. And then I think that's it. That's majority. For the label, you can either show it like that or at the bottom. So depending on how you want, but for my case, I prefer not to show any or that. And for this one, I usually use 0.5 to show a small annotation of the slab. And there we have it. So you can see bottom one, the total number of bars, the bar size, the spacing, and the bar length. So for each and every one of them, then just come here to the slabs, right click. For us to change the distance, you're just going to go here, analysis, then delete and select all the bars in all the stories that you're. After that, it's going to give you the report on how it has performed, the top, the bottom, every single bar. So click on X, close, and now we have the same spacing. Okay, so that's the way we usually do it. The analytical one, this is the model that we were working with. There it is. So you can either take photos of this, you can save the picture, you can copy it, you can have it in the report if you need it. So for my case, I don't need it, just close it. That's the way it is. And this is the center of gravity for different, and the center of inertia for story 2, and this one is now story 1. And there we have it. Yeah, I think it's clear. And the only thing remaining is just exporting to Prota detailing. So just click here. So it's interactive and automated detail drawings. Okay, so it's loading everything that we have here. Then it's gonna bring a dialogue. So from this end is rather simple. Yeah, so you come here, auto generated detailing, click on that. Then over here is when you specify what you want. Do you want it to be inserted in a sheet? If so it's all of them. Yeah, so all of them are inserted in a sheet. If so, you specify the sheet size. You want A0 or you want A0 Prota horizontal. You specify there for the column, elevation, for the beams. Then you specify also the scale that you want. So for this one, let's go with 50. For the columns, let's go with 60. For the elevations, let's adapt 60. Application 60. The plan, let's go with 60. And for the pad, let's remain at 25. So click on that, and then we're gonna say insert quantity table. So this one is gonna give you a small quantity takeoff of what you have. For the options, you can select different things. If you want it to have show the top, do you want it to display maybe the column nodes, the dimensions I want them? Do you want alternative? Do you show the number of bars? So here is where you select a lot. But if you already selected back in Prota, you don't need to come back here and select again, because they're already embedded into the settings. So yeah, so here's where you're gonna select everything that you want. So for my case, I'm okay, I'm content with it. So just for the column elevation, I just need for maybe 1 story. But for work, I'm just gonna leave it as it is. Or let's just have all of them because they're slightly different, because it's a ramp. Just click on draw, then click on any blank place on your drawing, and it's gonna draw them. So here we have it. Although the scale is very small, you need to change the scale. So there you have the detailing for the columns. It's very small. Over here we do have the quantity takeoff that I was telling you, a small BQ prepared, the codes used, the soil parameters over here, everything we have. So this is the way they look. Over here we have the beams, detailing on how they look. We have the pad footings. Yeah, and this is showing you on the way to reinforce the concrete bar beam schedule. So if you want a section of this, you just come here to a plant section, just click on it, select the name that you want, show intermediate elements, and show the rebars also. There we have it. Okay, so this is the way it looks like. So it's showing on the other side of the slab on how the reinforcement has been done. So back to Prota over here, the views actually, then you go to the 3D rebar model, and you can have the whole structure in 3D, so like so. So you can see the column rebars, how they look like that. Then you can have the wall, if you have the wall rebars but you don't have any walls here. Then you can have the pad, and you can see the pad like that. So it's a really nice, it's a really good software, great software. It's a great software. So there we have it. It's very beautiful. So from this other end, we can do a lot over here. After you're done, you can either export it to an external software, which is DWG or DXF, and then you can edit it in AutoCAD to your specifications. But this is just a brief on how you can do it. Okay, if you want a staircase real fast, you can just get it from here. So it's a really nice software. If I was to change this, I'll just come here, ProtaStructure, detailing, and I will change the scale, and everything will be better. Come here to the project parameters and manager. Then you specify over here. Then you specify what your project is. You can actually look at the statistics of your project, how long it's going to take, columns, the number of columns per floor. You can have it in a 3D view like so. You can have it in text file. You can just read it like so. So it's pretty great, extremely great. You can have a foundation. You can have maybe column and releases. You can have quite a lot here. So console back here. So there we have it. You see right now it's more spacious. If I need just to move it, you can just select it like that, just like AutoCAD. Press M for move, then just slightly move it to where you want. Maybe you want to place it maybe here, because although is on, that's why it's behaving like so. So I click it, then I just put it there like so. So I place it there like so. Basically that's the way it's done. And then after that, you're just gonna save drawing, so as a DWG, so ramp design. So now you can close. Yeah, so thank you so much for staying up to the end of this video. I know it was a bit technical, but it was something that can be easily done, and that's the way we design an RC ramp. Very easy. If you have any questions, kindly contact me on my email address, or feel free to leave a comment. If I've missed a step, or if I've not explained anything clearly, just comment in the section. So thank you.